The James Webb Space Telescope has once again stunned the world. For our entire existence, we've operated under a set of basic cosmic rules, known as the cosmological principle. This is the foundational idea that our universe, born from a single event, is essentially the same everywhere and in every direction. It's the bedrock of the standard model of cosmology, everything we think we know about our reality. But what if that foundation is showing cracks? What if the most powerful telescope ever built is finding clues that this fundamental rule is incomplete? For decades, the prevailing view has been that the universe is, on the largest scales, uniform and without any special direction. But scattered hints have emerged suggesting something is off. Now, the James Webb Telescope is peering into the dawn of time with such clarity that it is uncovering anomalies that scientists are struggling to explain. At the same time, a Nobel Prize-winning physicist, who helped build our current model of the cosmos, is sounding the alarm that this very model is in jeopardy. These new discoveries are forcing scientists to consider a theory once relegated to the speculative corners of physics. A profound theory which implies that our Big Bang was not the true beginning, but merely an event happening inside a vast, unknowable parent reality. The rulebook of reality. To understand why astronomers are now so deeply engaged in this puzzle, we first need to appreciate the rulebook they thought they were playing by. It's called the cosmological principle, and it's a deceptively simple idea with profound consequences. It states that, on the largest scales, the universe is both homogeneous and isolated. Homogeneous implies that no matter where you are in the universe, it looks roughly the same. There are no special places. Your cosmic neighborhood has the same basic components as 1 billion light-years away. This faint light from the dawn of time is almost perfectly uniform. Our standard model of cosmology, the theory describing the 13.8 billion-year history of the universe, is built entirely on this assumption. This implies that every calculation for how galaxies form and how the universe expands relies on this principle being true. But for years, there have been whispers that this perfect picture has been isotropic. Implies that no matter which direction you look, the universe also appears the same. There's no inherent up or down, no cosmic compass etched into the fabric of reality. Think of it like being on a vast, perfectly calm ocean, where the water extends to the horizon uniformly in every direction. This principle isn't just a guess. It's an observation baked into the afterglow of the Big Bang. It's a foreglow of the Big Bang. The first ominous cracks. Long before JWST, probes studying the cosmic microwave background found strange, nagging anomalies. Scientists analyzing data from the WMAP and Planck satellites found a peculiar alignment in the temperature fluctuations of the early universe, a pattern they provocatively nicknamed the axis of evil. It seemed to suggest a preferred direction, or axis, aligned with our own solar system. A statistical improbability that hinted our place in the cosmos might be more significant than the cosmological principle allows. For years, these anomalies were heavily debated, often dismissed as statistical flukes or errors in the data. Most cosmologists held fast to the standard model, confident that with better observations, these mysteries would dissolve. Then there was the CMB cold spot, an unusually large and cold region of the sky that standard models struggled to explain. But they didn't dissolve. Instead, with the arrival of the James Webb Space Telescope, the problems have become deeper and more complex. The whispers have grown into a roar that is now impossible to ignore. The Nobel winner's warning and the Hubble crisis. Enter Nobel Prize-winning physicist Adam Rees. Rees won his Nobel for co-discovering the accelerating expansion of the universe, driven by what we call dark energy. His work was fundamental to building the very standard model of cosmology that is now under strain, and he is one of the leading voices warning that we have a serious problem. It's called the Hubble tension, and it's at the heart of what some now call a crisis in cosmology. The problem is straightforward. There are two primary methods for measuring the universe's expansion rate, and their results don't agree. But then came the James Webb Space Telescope. With its incredibly sharp infrared vision, JWST was tasked with rechecking these local measurements with unprecedented accuracy. The result: Webb's observations have strengthened the case for the higher value. There appears to be no significant error in the data. This implies that the tension is real. The discrepancy isn't in our telescopes. It may be in our understanding of the universe itself. As Adam Rees has noted, with NASA's flagship telescopes reinforcing the numbers, the problem can no longer be dismissed. It suggests our standard model is missing something fundamental. This gives a value of about 67 kilometers per second per The second method looks at the local, modern universe. Astronomers, including Reese's team, measure distances to nearby stars to calculate the expansion rate directly. This method consistently gives a higher value, around 73. The first method looks at the early universe, the cosmic microwave background, and uses our standard model to predict how fast the universe should be expanding today. For years, many hoped this discrepancy was a measurement error. Webb's puzzling discoveries at cosmic dawn. The Hubble tension isn't the only puzzle Webb is presenting to cosmologists. As it peers back to cosmic dawn, it's finding things that challenge our models of cosmic evil. It has been found that some galaxies are far more massive and well-structured than our theories predicted for such an early stage of the universe. According to the standard model, galaxy formation is a slow, bottom-up process. Yet JWST has found galaxies with masses comparable to our Milky Way when the universe was less than 1 billion years old. At first, these discoveries were so jarring they prompted sensational headlines. The problem is very real. These unexpectedly mature galaxies challenge the established timeline of cosmic evil. While some studies suggest that rapidly growing black holes might be making these galaxies appear brighter and more massive than they are, attention remains even after accounting for this. Furthermore, Webb is finding evidence for supermassive black holes forming in ways that challenge our assumptions, supporting theories of direct collapse where black holes can form from immense gas clouds without a star dying first. This could help explain how black holes got so big, so fast, but it also reveals just how much we have yet to learn. Everywhere Webb looks, it is refining our theories and adding weight to the Nobel laureate's warning that our model of the universe is incomplete. The story of cosmology is being rewritten in real. These are the biggest questions humanity can ask, and we are getting closer to the answers every single day. If you find these cosmic mysteries as fascinating as we do, and want to stay on the cutting edge of what we're learning about our universe, make sure to subscribe and click the bell icon so you never miss an update. Your support helps us dive deep into these incredible topics. Now, let's get back to one of the most profound theories being considered. Universe inside a black hole. With the standard model facing pressure from the Hubble tension and Webb's early galaxy discoveries, theoretical physicists are being forced to explore ideas once considered fringe. One of the most mind-bending, though still highly speculative, theories is known as black hole cosmology, a model pioneered by physicist Nick. It proposes something staggering. Our entire observable universe exists inside the event horizon of a black hole. According to this model, the Big Bang was not a beginning from an infinitely dense singularity, a point where the laws of physics break down. Instead, Popvaski's model suggests that matter collapsing into a black hole does and get crushed to a single point. It rebounds in a big bounce. They are no longer just potential statistical flukes, but could be interpreted as hints of our universe's true nature. While the James Webb Telescope has not delivered a verdict on a cosmic axis, it is precisely the kind of instrument that could find such evidence by studying hundreds of thousands of galaxies. The search is on, and if a statistically significant alignment is ever confirmed, it would be the first real observational hint that we are living inside another reality's object. This rebound creates a new, expanding universe on the other side of the black hole's event horizon. It provides a physical origin for the Big Bang, framing it not as an event from nothing, but as a physical process within a larger reality. And here is where it becomes truly fascinating. The theory makes a testable prediction. If our universe was born inside a rotating black hole, that spin could have imprinted a subtle preferred axis onto our cosmos. Our universe, in this scenario, is the child of a black hole from a larger parent universe. This isn't just a wild guess. This framework is intriguing because it offers potential solutions to some of cosmology's puzzles. Suddenly, those old, debated anomalies like the axis of evil are viewed in a new, speculative light.